Hi, students. Let's look at this question here, which is on application of integration taken from the year 2022 MGS AMF Sec 4 paper to question 9. Okay, so let's go into this proficiently. So the diagram shows part of the curve, this curve here, okay, where y is equals to 3 minus 4 over 2x minus 5, cutting the x-axis at r here, which is given, then the tangent at p, which is this point here. Okay, where is this point here? This is our p. So let our p then cuts the x-axis at q. So this is q. Okay, so given that the normal, the cut at p is parallel to this line. Okay, so meaning to say, if I were to draw a line equation which is 90 degrees to the tangent like that. So this is a normal here. This normal will be given by the m normal will be parallel to this line. So this line here, it will be -2. The gradient here is -2, right? So essentially what we need is that this is -2. We need m tangent is we know that m tangent multiplied by m normal is -1. So we can just find the normal of the tangent there first. Okay, so that's that. Then given that the normal, okay, so to find the equation of tangent at point P. So essentially point P, I need to let this be, let's say, let point P be AB, or rather XY. We could actually just find the AB. Okay, so this guy here, what we can do is find the x coordinate of point P, okay, using the m tangent there. So we know that here m tangent multiplied by m normal, it will be -1, right? So m tangent is actually just we know m normal is -2. M tangent is this guy here. Yeah, and this is, so m tangent will be half, right? From here, we know that m tangent is also dy dx. Okay, so just dy dx here. Then we solve for the x coordinate. So differentiate with respect to x for this over here. Then we can find the x coordinate of p. So 2x minus 5 equals a half. So this case, differentiating 3 will be 0. Okay, or maybe I just rewrite this on d dx. Okay, that's 3 minus 4 2x. So remember, we need to use chain rule for this part here. This part here. Okay, so that just remember to differentiate this chain. So differentiating 3 will be 0. Then differentiating the outer layer, this is -1, you multiply below, right? -1. Then 2x minus 5. -1 minus 1 will be -2. Then multiply by 2. Differentiating 2x minus 3 is 2. And this is half. So this will give us a 4. This is 8 over 2x minus 5 square. Okay, equals to half. So I will get 2x minus, cross multiply, 16. So 2x minus 5 will be plus minus square root 16. So that will give us x equals to 4 plus minus 4 plus 5 over 2, which is actually is either half or 9 over 2. Okay, so you look at the diagram carefully. This x coordinate here has to be more than 3.167. So this, you need to reject this, okay, as x is bigger than 3.167. This is 0.5, right? So you need to reject this. So you could take 9 over 2. Okay, so essentially the x coordinate of this will just be 9 over 2. So this will be 9 over 2 over here. So to find the value of b, we just need to substitute 9 over 2 back into this equation to find y. Okay, so that's it. Y would then be 3 minus 4 over 2, 9 over 2 minus 5. I think you'll get 2 there. 2. Okay, so coordinates of p are 9 over 2, comma 2. Okay, that's it. Great. So we have 9 over 2, comma 2 here. Great. We got the values ready. This is 9 over 2. Then once we've done that, we can find the equation of tangent. So equation of tangent will just be we know that the m normal is half, right? That's what we got just now. Half. Okay. So equation of tangent. You use y minus y1 equals, okay, you can use what do you call it? Y equals mx plus c, but I'll prefer this. So y minus 2 equals a half, then x minus 9 over 2. Then we just expand everything, half x. 9 over 4 plus 2 we'll get is -1/4, right? So this will be y equals a half x -1/4. Okay, that's that. So we're going to look at the subsequent part, which is part 2. So for part 2, we have this, previously we already found this equation of tangent here, which is y equals to half x minus 1/4. Okay, we need to find the shaded area. So what we can do is actually just find this area of this triangle here, this entire thing. Okay, minus of the triangle of the area under this curve here. Okay, so that's the idea there. So the required area, I'm just gonna take this rectangle here, this entire thing, which is here. Okay, just half times base times height. Then what I'm gonna do is actually just minus off the area under this graph here. So this will be what I want to find. Okay, minus this. Okay, then I'll get the resultant area of the shaded region. Okay, so that's that. Now before that, what we need to do is actually just find this Q here, because the length here will very well depends on the value of Q here, right? Okay, so using the what do you call it, the equation of tangent, we could find the coordinates of Q. So when y equals to 0, what we can get is actually 0 equals to half x minus 1/4. Then this will be x half x equals to 1/4. So we know that x is equals to half. Okay, so this will be half comma 0. So the length here will just be 9/2 minus of half. Okay, that will be 9/2 minus of half. Then the height here would be nothing more than that, because it's 2, right? Okay, the height here is 2 units, because this is 2, this registers a 2, so this is a 2 units here. Okay, so we get this 2 units. Okay, that's all. So the required area, this is half, 9/2 minus half would be, it will be 4. So this will be half times base times height minus of the integral from 3.16. This is 3.167 to 9/2. Okay, so 3.167 9/2. Then the y will just take the curve equation, which is 3 minus of 4/2x minus 5 dx. Okay, that's that. This will give us 4 minus of, integrating 3 will be 3x. Integrating this will be, remember this is a ln 2x minus 5 divided by 2, because the coefficient of x is 2, right? This is where a lot of students will forget. The key calculator for this value here, just substitute. They didn't ask for exact, so I'm gonna just substitute 9/2 inside. Okay, this in, then the rest is just calculator work. You get 2.20 square units. Okay, so then you just leave in 3 as a. So that's how we do this question here professionally. If you have any questions at all, please do let us know, and I'll see you in the next question.